In this demo, I'm going to demonstrate device commands with an Arduino Uno using the default IoT connectivity model. Here I have the IDE that's available at the Arduino website, and you can see here that we've got some C code, which is the native language that you'll develop with against the Arduino. This is the fine IDE, but my preference tends to be Visual Studio, and there's an add-in that I'm using here from Visual Micro that actually allows you to leverage your Arduino for creating, Visual Studio for creating sketch projects. Here you can see I've got the same code for a web server that was created by zoomcat, which I've taken and repurposed here. A couple of variables here, the MAC address for the device. As you can see, it is connected to the internet and the network over a Cat5 Ethernet cable. I'm setting an IP address statically to it, setting my default gateway subnet, and then assigning a port number of 8088. Next, in the setup method that gets called upon initialization, I'm basically going to initialize the pin number 9 as an output port, and then basically default the LED on the board, which you'll see here in a moment, to off. I'll then go ahead and start up the Ethernet and enable the server to start listening for commands. You'll see throughout the code some calls to serial.println. This is basically just writing out the serial port, which is useful for debugging purposes. Next, you see here a loop, and in the loop I'm basically going to go ahead and check for server availability, and upon a client connection I'm going to go ahead and iterate through the request that is received, and I'll cap that at 100 bytes or 100 characters. And then I'll basically just concatenate that to this variable here, string variable here called read string that you can see I defined up here. And then once I verify that the request has ended by the introduction of a new line character, I'll go ahead and just print that string again for debugging purposes. And then here I've just got some simple HTML code just to provide some visual feedback to the user. And here's where I'm actually going to take the request. I'm going to parse it for the existence of two strings representing the command. LED equals on, LED equals off, and toggle the LED accordingly. So at this point, what I'm going to go ahead and do is just right click on the project, go to debug, start new instance, and you can see some feedback here at the bottom letting me know that I've occupied 14 KBs of 32 KBs, so a very small footprint. And at this point, we should be able to go ahead and connect to the server. So I'll go ahead and come out here to my browser, and I'll go to the IP address, port 8088, and you can see here that the server is responding with that HTML. And now to issue a command, I'll go ahead and just set the LED to the on position, and you can see now that the LED is on, and equally I'll go ahead and set that to the off position, and now the off command is received, and I can toggle that back and forth. So pretty straightforward. That's sending commands to the Arduino using the default connectivity model, which of course assumes that the device itself is addressable, and obviously in this case I'm using an IPv4 address, which really wouldn't be practical in a real scenario. Typically you'd have IPv6, maybe using VPN to bridge the connection, and it's really the device's responsibility to set up the server service API and expose that API for command receipt.